Hello everyone, my name is Viraj, and today we'll be looking at the fifth problem from the CP-31 sheet by TLE Eliminators under the 1000 rated questions. Let's go. So I've moved on to my sheet over here. I've ticked off 1000 and fifth problem, monsters. Let's see this. Monocarp is playing yet another computer game, and yet again his character is killing some monsters. There are n monsters numbered from 1 to n, and the ith of them has AI health points initially. Monocarp's character has the ability that deals K damage to the monster with the highest current health. If there are several of them, one with the smaller index is chosen. If a monster's health becomes less than or equal to 0 after Monocarp uses his ability, then it dies. Monocarp uses his ability until all the monsters die. Your task is to determine the order in which these monsters will die. Alright, let us quickly look at the generalization of this problem. Very simple. They are saying that they will give you n monsters. They will be indexed from 1 to n, and they will initially have some health that will be represented in an array. Let's say A1, A2, A3, A4, so on till AN. Now, of course, who likes monsters, right? We want to kill them. So Monocarp has this killing ability of K, which means that when I hit a monster, his health goes from his current health to whatever that health was minus K. So for example, I use this power on A2. So this number now goes from A2 to A2 minus K. Let's say next time I use this on A4. So this goes from A4 to A4 minus K and so on. This gets repeated. So on till monsters die. Now this thing that we are doing, we are killing monsters, has some rules. First of all, we don't use this killing power or this killing thing that we do on any monster. The monster who has the current highest health, okay, let's say this current highest health, we only do this attack on that monster. And of course, it can happen that many monsters have current highest health. For example, maybe A3 also has current highest value right now. Let's say A5 also has that. Let's say AN also has that. So which monster to do now? Not everybody. I choose the guy who has the lowest index. So I'll choose A3, which means I choose the guy which has the current highest health and also in that the lowest index. I hope this is clear. So I keep on doing this process. I pick the current highest health monster, whichever has the lowest index if there are many in that same scenario, and beat that guy, and his health goes from whatever that is minus K. Then again, and I keep on doing this process till every monster has a health less than equal to 0. Less than equal to 0. You can say less than equal to 0. This happens with every monster. That means that monster dies. Now, there is of course going to be an order in which these monsters die, right? When you do this process, maybe A4 dies first. Then maybe let's say AN dies. Then maybe let's say A2 dies. We don't know. We have to actually determine this. That is what is asked in the question. Tell me the order in which they die. Following, of course, these two rules. Okay, I hope the problem is clear. Let's quickly glance at one test case. Let's look at, let's say, test case number last. Okay, you have been given something like this 4, 3, and then 2, 8, 3, 2, 2, 8, 3, 3, 5. Now in this case, this means n is 4, k is 3. Now let's try to hit. Who is the largest guy right now? 8. So I'll hit this guy and this goes to 5. Now who is the next highest guy now? This is also 5, this is also 5. So I need to choose the person who has actually the lowest index. Okay, so out of these two 5s, I choose this 5 again, which has the lower index, very obvious. And I can make his health 2 now. Now let's take the next highest. Again, now this is 5, so I can make this 2 now. Now there are 3 over here given that is the next highest, so I'll make this 0. And now this guy has been dead because it has reached less than equal to 0 health. So if this is 1, 2, 3, 4 index, then I can just note down, okay, which is the first guy now to die? Third guy. Okay, now let's do this move again. Who dies next? I have the highest value as 2 and it comes 3 times. So I choose the one which has the lowest index 1 and this goes to 0. Now this guy is dead. So I can write down 1 over here. Then who do I eliminate? This guy, because there are 2 2. So I choose the one which has the lower index. This goes 0. I can note this down that, okay, the second monster has now been dead. And then finally this goes 0 and I can note this down 4. So my order becomes 3, 1, 2, 4. Let's go back. 3, 1, 2, 4. Yes, voila. So I hope the problem is clear. You can again pause the video and do this for the other two cases also. And I think they have given you a very neat explanation also over here. So it will become very, very clear, very, very easy. How is this order coming and what is that answer? All right, great. Now let us discuss the time complexity I am expected. I know that test is allowing me 2 seconds. So that means roughly like a 2 into 10 raised to 8 order. But it has been given that in a test, there are test cases. Although it has been very nicely written over here that sum of n over all test cases doesn't exceed 3 into 10 raised to 5 order. That means I don't need to bother about these test cases. I can directly compare over here. What will I do? I'll say that, okay, one test allowed me 2 into 10 raised to 8 operations. And n is given roughly in 3 into 10 raised to 5 order. So can I create a solution that looks like O of n? Yes. A little larger, O of n log n? Yes. A little larger, maybe O of square root of n also. All of this going to work. But if I go a little larger, n square, a problem. And anything below this, of course, works. Which means I know that solutions like this are promoted, but solutions like this are not. And this is my expected time complexity. Now, why is this helping me? This is helping me as expected. I know that I now have a brief idea on what solutions I would actually try to make. I don't want to go anything in n square order. Great. Now let us start with the problem. I hope this part is clear. Now there needs to be a very small and clever idea, first of all, that should come to mind. I'll quickly note this down. When we did this simulation also, and you must have also done the simulation, tell me if you agree to this idea. We don't start to write the monsters who die before each monster's health is less than equal to k. What does this mean? When we attack these monsters, their health decreases. But do you think that that guy is dead if that health is not reaching less than equal to 0? No, it is not. Now imagine that, let's take the previous example only, 2, 8, 3 and 5. Now when k was given 3 to you, you started killing people. Now the always highest guy has to be killed. Now tell me, the highest guy right now is still greater than k in health terms. So you would have decremented this and this went to 5. Now the highest guy still has greater than k health. So again decremented. Again. But when did you actually note down? When this process went from 2, 5, 3, 5, then this went to like 2, 2, 3, 5, then 2, 2, 3, 2. Now see very carefully. Every monster has reached a health less than equal to k. This means as soon as you click or hit the highest monster which has the health, because every monster has less than equal to k health, the highest monster will also have less than equal to k health. And from now on, the hits will start happening in such a way that the monster just dies. See, you hit this 3 guy, he's dead. Next time you hit this 2 guy, dead. 2 guy, dead. 2 guy, dead. And you have 4 consecutive hits where monsters keep on dying. This is a very important idea because now this tells me that first of all, whatever is the initial health of the monsters, they don't go in this dying phase till their health drops less than equal to k. Which means using this idea, I can do something very cleverly. Before I even start off by some sort of a simulation, every number that is AI, for example, can be reduced down from AI to AI mod k. Or when this value, if let's say drops to 0, then simply AI becomes equal to k. What does this mean? What I've done is, if AI is an initial value that you start off with, you make sure that you extract 3333 in this case when k was 3, 3333 hits, and then you figure out what's the n health that will be left if you have taken a modulo with k, modulo with 3, which means the remainder health. Remainder health turn out to be 2. Do this for everyone. Do this for this. So 2 mod 3, this turns out to be 2. 8 mod 3, this turns out to be 2. 3 mod 3, this turns out to be 0, which effectively means that this initial health was only divisible by k. Let's not worry. we can actually make it back to 3, because I know that if somebody initially has a health of 3 or 3's multiple, then somewhat or the other, I want to make sure that there is still k enough health left, because I want to kill that guy later on. So I'll say, okay, 3 guys still remains 3, and then 5 mod 3, this becomes 2. So I know that out of all the different healths that are given in the initial period, if every health is boiled down with this formula, a lot of my, you can say, futile attacks which will happen but will not make the monster die will come into picture, and they will automatically go aside, because at the very end, I'm just concerned with the order in which these monsters die. The initial attacks which are never making the monster die don't matter to me. And this is a very smart move. Now, this is very good because if you look at AI values, they were in 10 power 9 order. As soon as you have 10 power 9 order of a value, and as soon as you do a mod k over there, you basically have now made every value, because of this whole initial, you can say, pre-computation that we can do, we have made every value come down from whatever that number was to a 1 to k range. 1 to k range. And now, since every monster has surety wise a value 1 to k in health, you can very well see and very well argue that as soon as you hit any monster, that monster is going to die, because every monster has a health less than equal to k. It has 1 to k range. So now all I would want to worry is just figure out who would die first, note their indexes down, and print that as my answer. Great. So now let's take this case only. I would have said that once I would have received something like 2, 2, 3, and 2, all I would want to worry is somehow figure out the largest guy. And if there are multiple largest guy, figure out who are coming first. So in this case, I would have first simply noted down 3, or 3's index rather. Index are 1, 2, 3, 4. So 3 is the largest guy. Let's note down its index 3. Then 2, you can say, you can imagine that this has been removed. Now you have 3 2's. So let's note down the people who have the lowest index. So 1, then 2, then 4. So 1, 2, and 4. Voila, this idea works. All right, I hope this makes sense. Let's take one of the other cases also and see how this works. Let's take the first case, okay? So you were given n3, k was 2, and 1, 2, 3 was given. Now let's modify. 1 mod 2, this still remains 1. 2 mod 2, this becomes 0, but I don't want 0 because 0 basically means that I did attack this guy, but I want to save this guy for the end because I want everything from 1 to k range. So I'll say this still remains 2. Then for 3, this is 3 mod 2, which becomes equal to 1. So now the modified health values have come from 1, 2, 3 to 1 to 1. Now let's figure out who's the largest guy right now. Let's note the indexes 1, 2, 3. Largest guy, 2, kill him. Note down the index. Now next largest guy is the value 1. It has 2 occurrences. So let's take the lowest index first. Let's take 1. Then let's take 3. And this is the answer, 2, 1, 3. Let's go back. Yes, 2, 1, 3 was the answer. All right. So I hope this makes sense. Very, very simple and very clever problem. You can pause the video, figure out some of the other test cases on your own. And I think this is going to make sense. Let's take one more sample case. I think it's going to help a lot. I have quickly drawn this for you. So I have N8, K4, and then I have drawn these healths. Let's first run our formula. 2 health monster, 2 mod 4, still remains 2. 15th health monster, so it will be killed. So 15 minus 4, minus 4, minus 4, till it reaches from 1 to k range. So that means 15 mod 4. This actually gives me 3. Then 12 mod 4, this is actually divisible. So that means I would do something like this. 12 minus 4, 8. 8 minus 4, 4. And then I'll stop there. So that means effectively 12 mod 4 is 0, which means I still make it 4. 3 mod 4 still remains 3. 5 mod 4 becomes 1. 8 mod 4 is divisible. It gives 0 exactly, so I'll still keep it 4. 4 mod 4 again is divisible, so I'll keep it still 4. And then 5 mod 4 equals to 1. So now I have the new healths with me. 2, 3, 4, 3, 1, 4, 4, 1. Let's mark the indexes on top of them. 1, 2, 3, 4, 5, 6, 7, 8. Let's see who dies first. So I have the highest values as 4 right now, and I have 3 occurrences of that. So I'll order them and see which comes first. So I'll use this index 3, then this index 6, and then this index 7. Let's kill all of these monsters. Now the next 3, 3, highest guy. So 2 and then 4, 2 and 4. Let's kill 3, 3. Then 2 comes one time. So let's use this index 1. and then 1 comes 2 times basically. So 5 and 8, 5 and 8. So answer becomes 3, 6, 7, 2, 4, 1, 5, 8. And this is going to be right. You can pause the video, just cross verify this answer according to yourself, do a simulation on your own, and you will see actually at the very end, even without using my algorithm, you will still get this answer, which means my algorithm actually stands. The argument is actually true. All right, so I hope this helps. Fun problem. Let us now look at the problem code. How do we actually bring this into picture? For that, I'll use a very clever sorting technique also, so that we are able to actually implement what we wanted. Okay, this is the code. Let's see what I've done over here. I have said that I will take the input of test case, then I'll take the input of n and k. Then I have a vector of pair of long called health points of the n size. Now why a pair? Because remember, every time I'm trying to store a value and correspondingly an index. So what's better? I might create, if a pair of two values, a key, a first and a second sort of something, then I'll be able to maintain values also. I'll be able to maintain indexes also. So it's the smart move. Yes, I hope this makes sense. So that means what I'll do, I'll run a for loop from 0 to n. I'll take the input of whatever that health point is, x for example, and then I'll say that, okay, ith health point is basically x, comma, what are the indexes? Remember, we want indexes in 1 based indexing. That's why I, if starts with 0, I'll say I plus 1. So every time there is a mapping that has been done in this health points vector, a pair of the current health, comma, its index. Current health, comma, its index. It's pushed back, or you can say it's stored one at a time. This happens. Great. I hope this is clear. Now let's run our main algo, the clever algo that we wanted. Since we know every range, every health value has to drop from 1 to k range, let's run a loop again and make my health points I of first become health points of I of first, dot first mod k. Dot first over here simply means this first value, which of course meant this was actually storing that health point. And now if this actually value after doing a mod k turns 0, this means it was divisible. If it was divisible, I need to leave at least k over there to bring it to range to 1 to k, as we see all those 3-4 test cases we just discussed. So I'll bring it back to k. Great. Now I have a very quick custom sort with me. Why did I use a custom sort over here? Because remember, what is our target now? Our target is, after all of this thing has been done, you somehow have to figure out the largest guy, then the other largest guys, then the other largest guys. And it can happen that largest guys have many occurrences. How we saw over here. We saw that when you started with 4 had 3 occurrences. So how will you maintain 4 first? And even if you do maintain 4 first, how do you maintain lower indexes first? This sort of requires a custom sorting. The idea is, on the current health points vector, because you have something as a health point, comma, its index maintained, you basically want the larger health points to come first. And if all the health points match, then they can be sorted on the lowest index first. So these are the 2 requirements. I'll quickly note them down over here. You want that larger, you can say over here, larger health points come first. You can say come first. And then what's the second requirement? If health points match, as in let's say for this pair, like 4, 3, 4, 6, 4, 7, these 3 pairs, 4, 4, 4 would have matched because they have the same health points. So now you want, if health points match, lower index first. Now what is larger health point? Larger health point means the first value of the pair. And then what is index? Index actually the second value of the pair. So let's go back to the custom sorting function that I've written. I have said that I want to sort health points.begin, health points.end, of course the whole health point vector of pair that I've created. And for each comparison of 2 pairs, this is just how index that we follow. I'll pass the pair A, I'll pass a pair B, and I'll try to compare A and B. Whether A should be placed before B, that's the question. Now let's see. If A dot first is not equal to B dot first, that means their healths don't match. If the health doesn't match, then who should come first? The guy which has the health value greater than the other guy. So A dot first will come before B dot first only and only if A dot first has a higher health than B dot first. And if this if condition is not true, that means health values matched. If that happened, then who comes first? The guy who has the index lesser than the next guy. That means A's index, A's dot second value, if it's lesser than B dot second, then place A before, else place A after. This is a very smart sorting move. It's called custom sorting. You can pause the video over here, give it a 2 minutes thought, maybe run this and see the output that comes out. And I think you will understand play around with this and be able to see what is the meaning of this whole custom sort that we have done. Great. Now, once this is done, my life is very simple. Now I have basically sorted all the numbers or the pairs rather in this health points vector in their exact order which I wanted. I know that they have been first placed according to their healths, and if healths match, then they are placed according to their indexes, which is lower index coming first. That means all I need to go in this health points vector and take out every pair auto it and just simply print it.second. I know the indexes are going to work. They are perfectly sorted for me. Let's print and then we'll change the line for the next test case. This works for all my cases, gets me accepted over here also on all these sample cases over here. And it's of course going to get me and accepted on the platform. Okay, I hope this makes sense. Let's quickly discuss the time complexity. You will have an n order over here simply to take the input. This is pretty much constant. Then on n order over here also, pretty much simple. Then this sorting is going to take a little bit of time. We know sorting will take something like an n log n order over here. And then if we look over here at the printing, this is n also. So I know that the larger time complexity node is n log n in this case. Now if I go back, n was given in 3 into 10 raised to 5 order. So if I place this over here, this is like O of 3 into 3 into 10 raised to 5 order of log of 3 into 10 raised to 5 order, which is roughly like writing, this is what it came up to be, something like 6 into 10 raised to 6 order. So I can briefly write this as 10 raised to 6 order. Okay, and this is going to work. Why? Because we had a comparison with 2 into 10 raised to 8 order for every test file. So this is working. Space complexity is simply O of n because that is the size of the vector that I created. You can say n into 2 rather because you have pair also, but it doesn't matter. 2 is just pretty much a constant factor. I can remove that. All right, so I hope you enjoyed this problem. A little bit about custom sorting, that was all there in this problem, and a greedy idea. Otherwise, I think the problem was very simple. Implementation could have been a trickier end, but then first time is always a charm. Now I think you are aware of how custom sorting works. So all the best after that. Great. So that is all that is there in this problem. I hope you like it. Thank you for watching.